Unit Testing in the EU Context Chapter 19 Roger P. It involves testing for each class and each instance of a class, object, packages, attributes, i.e. data, and the operations, also known as methods or services, that manipulate these data. Rather than testing an individual module, the smallest testable unit is the encapsulated class or object. This is so because a class can contain a number of different operations and a particular operation may exist as part of a number of different classes. Consider a class hierarchy in which an operation X is defined for the superclass and is inherited by a number of subclasses. Each subclass uses operation X, but it is applied within the context of the private attributes and operations that have been defined for the subclass. Because the context in which operation X is used varies in subtle ways, it is necessary to test operation X in the context of each of the subclasses. Class testing for EU software is the equivalent of unit testing for conventional ware. Unlike unit testing, class testing for EU software is driven by the operations encapsulated by the class and the state behavior of the class. Integration testing. There are two different strategies for integration testing of EU system. The first, i.e. thread-based testing, integrates the set of classes required to respond to one input or event for the system. Each thread is integrated and tested individually. Regression testing is applied to ensure that no side effects occur. The second integration approach, i.e. the use-based testing, begins the construction of the system by testing those classes, called independent classes, that use very few, if any, of server classes. After the independent classes are tested, the next layer of classes, called dependent classes, that use the independent classes are tested. This sequence of testing layers of dependent classes continue until the entire system is constructed. Cluster testing is one step in the integration testing. Here a cluster of collaborating classes, determined by examine the tree-and-object relationship model, is exercised by designing test cases that attempt to uncover errors in the collaborations. Validation testing in a new context. The validation of EU software focuses on user-visible actions and user-recognizable output from the system. To assist in the derivation of validation testing, the tester should work upon the use cases that are part of the analysis model. The use case provides a scenario that has a high likelihood of uncovered errors in the user interaction requirements. Conventional black box testing methods can be used to drive validation tests. In addition, test cases may be derived from the object behavior model and from event flow diagram created as part of EU. Test case design for EU software. An overall approach to EU test case design has been defined by BARA. Each test case should be uniquely identified and explicitly associated with the class to be tested. The purpose of the test should be stated. A list of testing steps should be developed for each test and should contain a list of specified states for the object that is to be tested, a list of messages and operations that will be executed as a consequence of the test, a list of exceptions that may occur as the object is being tested, a list of external conditions, i.e., the changes in the environment external to the software that must exist in order to properly conduct the test, supplementary information that will aid in understanding or implementing the test. Unlike conventional test case design, which is driven by an input-process-output view of software or the algorithmic detail of individual modules, object-oriented testing focuses on designing appropriate sequences of operations to exercise the states of a class. Fault-based testing. The object of fault-based testing within a new system is to design tests that have a high likelihood of uncovering plausible, i.e. hidden, faults. Testing a SQRT operation that returns errors for negative numbers. Try the boundaries, a negative number close to 0 and 0 itself. 0 itself checks whether the programmer made a mistake like if x greater than 0, calculate _the_square root instead of the correct If x equals 0, calculate underscore the underscore square underscore root. Consider another example. If A and B vertical bar C. Possible errors could be and should be vertical bar was left out. Need of parenthesis around B vertical bar C. For such plausible faults, we need to design test cases that will force the incorrect expression to fail. Website testing. Web app testing is a collection of related activities with a single goal, to uncover errors in web app content, function, usability, navigability, performance, capacity and security. WebInc and other project stakeholders participate in the web app testing. The web app testing process begins by focusing on user-visible aspects of the web app and proceeds to tests that exercise technology and infrastructure. Testing for web apps. The objectives of testing within a WebInc context. One should consider the dimension of quality. Dimensions of quality. Quality is incorporated into a web application as a consequence of good design. It's evaluated by applying a series of technical reviews that assist various elements of design model and by applying a testing process. Dimensions of quality. Both reviews and testing examine one or more quality dimensions. Content is evaluated at both a syntactic and semantic level. At syntactic, spelling, punctuation and grammar are assessed for text-based docs. At semantic, correctness, consistency and lack of ambiguity are assessed. Function is tested to uncover errors indicate lack of conformance to customer requirements. It's assessed for correctness, instability and general conformance to appropriate implementation STD. Structure is assessed to ensure that it properly delivers web app content and function that is extensible. New functionality may be added. Usability is tested to ensure that each category of user is supported by the interface and can learn and apply all required navigation syntax and semantics. Navigability is tested to ensure that all navigation syntax and semantics are exercised to uncover any navigation errors dead links, improper links, erroneous links. Testing for web apps. Performance, tested under a variety of operating conditions, configurations and loading to ensure that the system is responsive to user interaction. Compatibility is tested by executing web app in a variety of diff-host config. On both the client and server sides. Interoperability, it is tested to ensure that the web app properly interfaces with other applications and or databases. Security, it is tested by potential vulnerabilities and attempting to exploit each errors within web app environment. Many types of web app tests uncover problems that are first evidenced on client side. Because web app is implemented on client side on diff config, diff platforms and in diff environments. Some errors may be there in the incorrect design or HTML coding. Errors are difficult to trace in three-layer architecture, client, server and NW layer.